Okay, we're back with the 2014 updated CAT, question 3. Now looking at part A, we're asked to factorise. We start by looking for a common factor first, but I can see there's nothing common to all three terms. So next we're going to assume then, because all three terms are there, that it's a double bracket quadratic. The factors of 2 are 2 times 1. The factors of 3 are 3 times 1, so there's not many combinations to try, actually. We want plus 1 in the middle here. I can see 2 times 1 is 2, 3 times 1 is 3. I can use a 3 and a 2. We're obviously allowed one negative, one positive sign because of the negative at the back. So if I do 2 times 1, and then I want the 3 times x to give me the 3x. Now to get positive 1 in the middle, I'd need positive 3 minus 1. And of course we've got time, we should check. Try expanding it back again. 2x squared minus 2x plus 3x minus 3. And I've got the 2x squared term, I've got the minus 3 term, and in the middle there is a plus 1x term. Right, part B. Looks scary, but I think if we just take our time. Here's a sequence. This is discussing whether it's a prime number or not. Here's the formula, so I don't have to find the formula, which is great. That formula should give me the sequence if I substitute a value for n. Prime number is one that can only, yes, we understand that. For the sequence of numbers where show that when n equals a, then u will never be a prime number. So we're told to let n equal a up here. Instead of n, we're going to write an a. So u equals a squared minus a plus a. Clearly minus a plus a would cancel, and I'd be left with a squared. So u equals a times a. Now let's think about the factors of u then. We're asked to show that u is not prime. Factors of u will be clearly 1 and itself, always. Factors of any number are 1 in itself. 1 times u gives me u. Now a is also a factor, because a times a equals u. You can write it twice, or you don't have to if it's repeated. And I know that a is not the same as 1, because it says that n is greater than 1, and n and a are the same thing, so a is greater than 1 as well. So clearly u cannot be prime, because it has at least 3 factors. As it has at least 3 factors. It might have more factors, actually. We haven't investigated any further, but we've certainly shown that it can't be prime number. Right, next page. Looks complicated. Write an equation for r in terms of t. Right, even if I don't understand, I can see there's a lot of brackets there, and I know how to expand brackets. So if in doubt, let's show off some skills. 5n squared plus 5n minus 4n minus 4. Now we cut down here and we'll expand this one, so I'm going to get minus 4n squared. It's tricky, 2 2's are 4, n times n is n squared. Then being careful of that negative, we'll get minus 2 times 3 is 6n. And expanding the last one, we'll get a plus 4n plus 4, and I've got minus 3 on the end. Right, gathering up like terms so I can show another skill. So I've shown one skill of expanding, even if I don't understand the question. Now we could show the skill of simplifying. So 5n squared minus 4n squared is 1n squared. We've got lots of n's here. 5 minus 4n is 1n. 1 minus 6 is minus 5n. Negative 5 plus 4 is negative 1n. And what I happen to notice, if you look up here at t, I'm starting to get something that's looking a little bit like t. Now if I had a plus 5 on the end, then r would be the same as t. which would be very easy because I want to write an equation for r in terms of t. So if I had plus 5 on the end, then r would equal t, and there's my equation. However, minus 4 plus 4 cancels out, and I've got minus 3 on the end instead of plus 5. So actually, I could write r as n squared minus n plus 5. Now to get minus 3, I'd have to subtract 8. 5 take away 8 gets me back to minus 3. So you have a wee look at that and check you understand that. Because then what's nice is we could write r is the same as t minus 8. And what I've done is write an equation for r in terms of t. So here's an equation that tells me how to find r, but using t. And along the way we've shown off some skills. Okay, part 3. Find the value of n when u is 91. So this is solving a quadratic equation. We know how to do that. We might just put the equals 91 on the other side. Before we factorise, of course, if this is quadratic, we're going to need to get 0 on the right hand side. One take away 91 must be negative 90. Now we can factorise, showing different skills as we go. We showed the skill of rearranging, the skill of simplifying. Now we're factorising. I'm thinking 10 times 9 is 90, and I'm looking for something that has a gap of 1 or can be used to make minus 1. So I'm feeling good about the 10 and the 9. To get negative 1, I think we'd need negative 10 plus 9. So therefore n equals 10 or negative 9. Now as far as we know, you can have, if we're talking about this sequence for u, and this refers to the sequence on the previous page, then I think u needs to be a positive number. So that's not particularly clear. We'll leave it as 10 or negative 9 there. Although it is part 3 of the previous question. So chances are we only want n equals 10 because negative 9 isn't a natural number. And if you remember back on the other page, u was a sequence found by substituting values of n that go 1, 2, 3, 4, 5. Alright, part 4. Another example of explaining why something cannot be prime. So let's have a look, and even if we don't understand the question, what could we do with this? We could factorise probably, show off some skills. Factors of 6, 2 and 3, 6 and 1. We want to get minus 1. So we'd need negative 3 plus 2. Now what have we done? We've managed to write u as one factor times another. So what are the factors of u? Factors of u are of course 1 in u, but also n minus 3 and n plus 2, because they are two numbers that multiply together to give u. So clearly u can't be prime if it's got at least 4 factors. There might be more. U has at least 4 factors, so cannot be prime. We're told that it will never give a positive prime number. We need to have a look at these two here and make sure that one of them couldn't be 1. n minus 3 needs to be greater than 0 and n plus 2 greater than 0, which means n would need to be greater than 3. So that we don't get a positive prime number for u.